So for question 4, we're going to be using product rule, but implementing it in a word problem. So 1 hour after a dose of X milligrams of a particular drug is administered to a person, the change in body temperature, Tx, in degrees Fahrenheit is given approximately by Tx equals x squared, parenthesis 1 minus x over 9, parenthesis, from 0 to 7. So again, be very careful. What is the input? Input is x, which is milligrams, and the output, which is y, is the temperature, body temperature. So be very clear, input, output. Okay, so for the first one, we're just going to plug 1 and 3 milligrams into the original to see what the body temperature will be. So I'm going to do this by hand and in the calculator. So we're going to plug 1 in for x, so 1 squared, parenthesis 1 minus 1 over 9, close parenthesis, get that answer. And then we'll plug in 3. 3 squared, parenthesis 1 minus 3 over 9, parenthesis. I'm going to do it by hand and in the calculator. So if we do it by hand first, we can just go to the calculator, parenthesis 1, close parenthesis, squared, parenthesis 1 minus parenthesis 1 divided by 9, close parenthesis, close parenthesis. If you open a parenthesis, make sure you close it. And we get about 0.89. 0.89. And we're going to do the same thing but plug in 3. A little calculator trick. If you hit second enter, it gives it back to you. And everywhere there is a 1 we plugged in, we'll plug in a 3. We'll plug in a 3. Hit enter, and we get 6. So, yes, we get the answer, but we're going to check it in the calculator as well with the table. So we're going to go to y equals, get rid of any other equations in there. I'm going to leave the derivative that we used earlier because that will help us later on. And we're going to go to y equals, and we'll put x squared, parenthesis, 1 minus x divided by 9, close parenthesis, enter. Then when we go to the table, again, make sure when you hit second window, it says Ask Auto. If it says Auto, then this won't work. You make sure it's Ask Auto. Hit second graph for table, plug in 1, we get the 0.89, plug in 3, we get the 6. Now this will be the derivative, we'll check it in a little bit. But getting the answer is one thing, but being able to explain it is another thing. So at 1 milligram, the change in body temperature is 0.89 degrees Fahrenheit. At 3 milligrams, the change in body temperature is 6 degrees Fahrenheit. Okay, so that tells me at this 1 milligram, at this 3 milligrams, what's the body temperature? And we have that. Now we're going to look for the derivative. So the original, we have t of x equals x squared 1 minus x over 9, which I'm going to write that as 1 over 9x. Means the same thing, but maybe a little bit easier for the derivative. But we have two things being multiplied, so that means we're going to do product rule. Remember product rule, derivative of the first one, so the derivative of x squared is 2x times the original first one, 1 minus 9x, plus derivative of the second one, so the original first one times the derivative of the second. Derivative of 1 is 0, derivative of minus negative 1 over 9x is negative 1 over 9. And again, let's clean it up before we start plugging things in and possibly making more errors and things like that. Just be careful plugging it all in. Be careful plugging it all in. So when we clean this up, 2x times 1 is 2x. 2x times negative 1 over 9x is minus 2 over 9x squared. Negative 1/9 times x squared is negative 1/9 x squared. The derivative would be negative 2/9 x squared minus 1/9 x squared would give you negative 3/9 x squared plus 2x, which then simplifies to t prime of x equals negative 1/3 x squared plus 2x. So again, this is a nice reminder that number one, did you do the derivative correct? And number two, can you simplify? Okay, both are very, very important. Both are very important. Now that we have the derivative, we can plug into the derivative. Now we have the derivative, we can plug into the derivative. So for the first one, it would be, we're going to plug in 1, negative 1/3 times 1 squared plus 2 times 1. We're going to plug in 3, negative 1/3 times 3 squared plus 2 times 3. Again, you can simply type it in to the calculator, see what you get, or we're going to use the table. To check in the table, we're going to go to y equals, y1 is the original, y2 is the derivative in the calculator. Remember that was math 8x, y1, x. Then y3, our derivative, make sure you type that in correctly. I'm going to put negative, not subtraction, negative 1 divided by 3, x squared plus 2x. Now again, if you want to put that 1/3 in parentheses, that's a good practice. Maybe I'll go ahead and do that just to kind of model it. Second, delete to insert parenthesis. Second, delete to insert close parenthesis. Okay, just a good practice to put fractions in parentheses. And I'm checking my work. If y2 and y3 are the same, that means we did it correctly. So let's see. Second graph. Notice 1 gives you 1.67, y2 and y3, and 3 gives you 3 for y2 and y3. So we know we're correct. We know we're correct. So we get 1.67 and we get 3. Now remember, what are we doing now? We're seeing how that body temperature changes. First one, we found out the body temperature change. Now we're finding out how that changes. So at 1 milligram, the change in body temperature increases. Why is it increases? Because it's positive, 1.67 degrees Fahrenheit per milligram. So it's always output over input, output over input. And then for 3, at 3 milligrams, the change in body temperature increases 3 degrees Fahrenheit per milligram.